Good afternoon, everybody, and thank you for joining us on today's webinar. I'm Kevin Greenway, and I'm really pleased to introduce alongside me today Rob Beekmans. And today, Rob and I will discuss the various HDX features available today for the modern workforce, some of which were extremely relevant in 2020 and again during 2021, as we see many employees working from home. A bit of housekeeping before I hand to Rob. The webinar is scheduled for 1 hour and it will consist of slides as well as live demonstration. And there will also be a couple of polls throughout the webinar, and would really encourage you to answer the polls and it would be really appreciated. And in addition, there will also be a survey, and this will be emailed to all attendees after the webinar. So again, we really appreciate your feedback here. Attendees will be silenced throughout, but given an opportunity for Q&A at the end of the webinar. And the webinar recording will be available shortly after, and you also have access to the slide deck that we're presenting today as a handout in the webinar panel. So for the first poll of the webinar, let's just see which of our attendees are already using Citrix today, just again so we can gauge our audience. So again, if you can answer this, would be really appreciated. And I'll leave the poll on screen for some seconds just to make sure we're capturing as much of the attendees as possible. So it looks like we have the bulk of the responses now. So if I share the results on screen, you can see that 83% are already using Citrix and 17% no. So Rob, it looks like you have a job on your hands to convince the 17% of the benefits. So that's great to see. And for the other Citrix users already out there, hopefully we can educate you on the latest and greatest recommendations. So we hope you enjoy the webinar. Thank you very much for taking the time out of your busy day. And we promise to, for anybody that's interested in seeing the inauguration, we promise to finish on time to get you there. So Rob, let me just give you presenter access, and it's all yours.
Thank you, Kevin. Now, thank everybody. Welcome. I'm just going to show my screen. It's easiest, and I can switch to the demo also. So, welcome again. I will talk about HDX, deconstructing HDX, showing demos. So I'll cover three major areas, or adaptive protocol, what it is and why we do what we do, because network conditions are subject to constant change. And then the power to adapt is what differentiates Citrix from the others. I want to show how we do things and why that really is true. Then I will focus on optimization. So how do we optimize? And what does it bring the user? This, of course, comes with demos, and that's just, you need optimization because everybody's working in Teams or in Zoom and so on. So we need to optimize things. We're working at home, we're browsing and doing lots of things. And then we have user experience, which of course is what Citrix drives. We are really focused on user experience. We are a top-down company where we focus on user experience, where some others are focusing more on management of devices. So I'm going to show you how we can make sure that the user has the best experience no matter where they are and how they connect. So before I dive into the protocol, I just want to do a quick highlight of what Citrix is. As you know, Citrix Virtual Apps and Desktops provide us with virtual desktops. But there's more to a virtual desktop than a virtual desktop. What type of desktop do your users need? Shared, pooled, pro graphics, maybe remote PC access that we saw a lot of last year in the beginning of the pandemic. And what's the difference between those things? When do you use what, and why do you use it? So what about hosting a desktop versus a server? And do you even need a desktop? What about just delivering an app? What about Linux users? Will they be supported? What kind of desktop do they need? These are various options you have with Citrix. But a desktop or an app is as good as the delivery method, the protocol that allows you to interact, experience the app or desktop. it is often worthwhile if we remember why a person would use a certain delivery method before we get into building things and deep diving. So let's do a few examples. Let's first talk about a physician. A physician is somebody who roams from patient room to patient room, requires more patient FaceTime instead of computer FaceTime. They have to be at the bed, they have to look at reports about medication and so on, and they are for the patients. They require fast roaming capabilities when they are the new patient and need their status, their medication, and so on. So they have follow me resources, printer, data, apps, and everything has to be secure. But when they work with patients, they are working on a tablet or a bigger phone, and they only need an app. But when they are in the office, they would need a full desktop experience because they have to write reports, and that's easier to do on a normal desktop. So data should be central, and let's say in the office you could have a thin client, a 10-zig thin client with a centralized desktop. It would be really applicable there. And when they roam, they have a tablet with them. And the next one would be a student. And a student, they don't need to have limited infrastructure, and they change classes every hour or so. Every time they change classes, they require new apps. So you have to be able to provide them with new apps fast. The apps will have to be updated also fast. Sometimes you have to push something really quickly to them. Right now, I have to adult children who are studying at university. They are studying at home. They have remote access, and they have their personal laptop where they connect to their school system through Teams or Zoom, and they have their documents in a school system or in Google Drive or on OneDrive, and that's how students work. And then we have, let's say, almost all of us, the remote worker, unable to work it to the office, work at home 1-2 days a week. That was the way it was. Or you are forced to work from home indefinitely, as during the COVID-19 pandemic. Everybody has already a traditional PC at home, but that's used by everyone at home, so that's not really secure. Things have been played on that. Things have been downloaded there, so you don't know for sure if nobody's listening or reading when you're doing something. So you need a secure remote access, and therefore a company-provided device, like let's say again a 10-zig client. You will see management capabilities of that real soon. A manageable client, secure, fast, perfect solution for that would is what they need. So with Citrix Workspace app, a user session will utilize Citrix HDX. With HDX, users get a rich, high-definition experience, allowing them to utilize smart cards, scanners, drawing tablets, as well as any app, regardless of the graphical requirements and capabilities. But HDX isn't a single technology. It's comprised of many technologies for different use cases, like HDX Media Stream for video and audio apps capabilities, real-time for voice and video, collaboration like with Microsoft Teams, Skype for Business, Zoom, and so on. HDX Touch to enable users to have a touch-based feeling in their session. And for those users who require 3D applications, we have HDX Rich Graphics. And with that, let me give a quick demo of HDX, what it does. I'm going to start there. I don't want to update. Can you go away? Yes. So, where is it? I'm going to do a rally in Finland. No, I didn't take this one. First, we have to have an ad in 5 seconds. It's really amazing that we get so many ads when we just want to watch a video of it. So this is Firefox running. We have no offloading to the client. This is pure HDX doing its best. And of course, this is just a video. I didn't upload, didn't take a high definition video. But if you look at this, this is really. I just was saying, like, we have to hope for a good connection. But this is pretty good if you look at the frame rate, and everything is going quite smoothly. There are no hiccups in the video while we are watching. So just want to show that HDX can also work without any offloading to the client. Let's get back to this one. So within the application layer of the TCP/IP model, we have the ICA protocol, which is comprised of numerous virtual channels, which provide us with printing, drive mapping, USB capabilities. In addition, ICA also provides us with different ways to encode and compress or visual components, so they take less bandwidth on the wire. Let's take a look at thin wire. Thin wire is one of the codecs used to take the user remote display and render and compress it to be sent across the wire to the endpoint. Thin wire's goal is to provide a good experience with low bandwidth and CPU usage. It does this through different techniques, all constantly, of course, and being improved. So thin wire is just one codec that ICA leverages, and ICA uses a combination of techniques to reduce the amount of data sent across the network, including network compression, command remoting, video streaming, image caching, and user intent. All these processes happen at the application layer. This is where Citrix Virtual Apps and Virtual Apps and Desktops has been focusing on optimizing the ICA protocol. These are really important processes that are running. And we have multiple ways of encoding the display, but which option is best? Let's look at a typical web. One of the first things you notice is that it's comprised of multiple types of media. So in white, first we have video and 3D content, which we have highlighted in white. We have also images, JPEG, PNG, it's highlighted in aqua. And we have text highlighted in teal. And there are different ways to optimize this content. Some approaches are better at video, while other approaches are better at text and images. And historically, users were stuck with a single approach, regardless of the content within the current session. And instead of selecting a single encoding scheme, like our competitors do, we let the protocol decide how to encode portions of the screen. With adaptive display, you will end up with something like this. For our video and 3D content, highlighted in white, we want to use H.264, because it's best at optimizing content that's rapidly changing. However, because H.264 has a higher hit on CPU usage, we want to limit how much of the screen it uses. For images, highlighted in aqua, we want to go with thin wire codec, which is optimized for static images. And finally, for our text, highlighted in teal, we want to avoid blurring around the edges of the letters, which would affect readability. Adaptive display will use overlay lossless technology to give it crisp letters. And in addition, ICA also provides us with different ways to encode and compress our virtual components, so they take less bandwidth on the wire. ICA and all implemented virtual channels are encapsulated within TCP at the transport layer and sent across the network. There's something important to understand about TCP. It's that as distance and latency increases between 2 points, the overall bandwidth utilization decreases based on TCP algorithms. That's really important to understand. I'm going to leave it here for a few seconds so you can read it again. To overcome the issues with TCP on high latency and high packet loss networks like a WAN, many third-party solutions utilize UDP instead of TCP. Unfortunately, UDP is unreliable. Your packages may be skipped or arrive in the wrong order. Citrix created a proprietary transport protocol that functions well on high latency and high packet loss connections, while still being reliable, unlike UDP. And the protocol is adaptive. It will automatically switch the user session between TCP transport and the Citrix Enlightened transport. So if a user is on wireless and changes location, adaptive transport will automatically switch based on changing network conditions. The user doesn't have to do anything for that. Now, before I go into a demo, I want to talk a little bit about Citrix Browser Content Redirection. It's one of those gems that is often forgotten. It's used with unified communication solutions like Zoom to offload to the client, but also in watching video or Google Maps or any web page if allowed to be redirected. And endpoints, they have abundant resources, and browser content redirection leverages that to give a great user experience without the need for a GPU in the virtual desktop. Lower cost for your environment, saving up to 70% of CPU resources. With that, you have better scalability. You can add more users per instance, and with that, you need less instances in Azure, and with that, your bill gets lower. And one other cool thing is, I will show you that in the demo, is that it will also allow the user to see the actual location of where they are working from instead of the Azure data center location. It helps when you order food or map a route. It's easier if it finds places around your location instead of around the data center. So let's show that. I have Chrome running, and here I'm going to move my screen down. Here I have the browser content redirection plugin extension installed. It's just available in Chrome, and then within Citrix policies you enable this, and you add the sites that you want to be redirected to the client. So the client is then doing the rendering, and it's merging that into your virtual desktop. So I'm first going to show a video with YouTube. Do this one, the roller coaster. I'm going to show. Now see, we are now it's now active. So now my client will be taking the load of the of YouTube. This is a great song, by the way. But I'm going to put this one. Yes, I agree. So this is now rendering. You see we have 7-8% CPU level going on. I can show the local one. If I see here, then let's take this one. And you see my local client is way more busy with CPU taking resources there. So this is almost nothing that it's taking. This is a multi-user Windows 10 environment running in Azure. It's 2 CPU, 8 gig RAM, so it's not that heavy. Because if I would take a heavy one, you would not really see the effect here. So that just shows like you can do a really you can show a real good video and still have a lot of users on your virtual environment. While not stressing the CPU, and your local client will take the CPU. Let's go to Google Maps. Where am I? Here am I. Google Maps. Now I'm first going to take maps.google.nl. This one, as you will see, I'm taking this down, is not optimized. I optimized google.com. So I have to enter the URLs there. So if I now check for restaurants, I will find the restaurants in Amsterdam because the data center is in Amsterdam. But I don't live in Amsterdam. I live far from Amsterdam. So let me take googlemaps.com. So that's my local. Now it's going to see also CPU is going down. And yes, I have to. So now I'm living right here. You can drop by for a coffee if you want, but we do it at 1.5 meter distance, if that's okay with you. You have to come before Friday because then we are in a higher tier of lockdown. So if I look at restaurants now, you see we have a number of restaurants around my place, not that many, but we have some. So it now sees my local location, which is, I think, pretty useful. And quickly, no, because otherwise I'm taking away Kevin's time. I would love to be in Paris again. As you can imagine, I have to move this up again. So here's the Eiffel Tower. Now we're going to do something fun. 3D. This instance in Azure has no GPU. This instance in Azure is a simple instance, a D2 something instance. So now I can do a Peter Pan around the Eiffel Tower. I know in this webinar, it will not really show that great. We will have videos released where you will see this better than you will see it now here. And you can try it also yourself if you're running Citrix. Just enable BCR and add google.com maps.google.com/star, and then you can do something like that. This is not possible with any other solution without a GPU in Azure. That's you see the CPU, of course, it's a bit higher because we are really doing something, but it's still quite low compared to if I would do this without offloading. And you could not do it without offloading. If we would not have browser content redirection, this option, this 3D option, would not be available in Google Maps. And with that, I want to hand over to Kevin, who's going to talk about unified communication solutions.
Thanks very much, Rob. That was really great, and hopefully everybody enjoyed that. And as Rob said, I'll now be taking the unified communications part initially. Let me just take presenter access back and share my screen. And I'll bring up the slide deck again. Okay, so as Rob mentioned, I'll be covering unified communications, and this is a really big and relevant piece again to the offloading capabilities of Citrix. And furthermore, unified communications or the collaboration tools are more important than ever with so many people working remotely. So the purpose of this first slide is to discuss a potential problem of using these types of applications in a virtual environment such as Citrix. And again, that problem is exacerbated more in a remote working environment. So the user's endpoints, user 1 and user 2 here, let's assume that they're both located at home and they both have a webcam and a headset, and their virtual desktops are either in the cloud, in Azure, for example, or they're in an on-premise environment. But in each case, the user's webcam or video stream and audio stream have to forward from their endpoint towards the virtual desktop, and the virtual desktop then has to convert that stream into either Teams or Zoom, whatever it is they're using, and then forward that audio and video stream natively either to the other peer or via the UC solution, which is typically cloud-based. And so the situation you end up with, hoping that one or two of these phrases.
Show your slides. Kevin, show your slides.
I'm not showing the slide.
No, you're showing the desktop.
Okay.
There.
Sorry about that. Thanks for the pointer. So you haven't missed anything, luckily. The point that I wanted to demonstrate here is that without any optimization, you end up with, again, one of two phrases, which hopefully translates well into French. It's trombone or the hairpin. And it's basically the effect of the call, whether it's video or audio, going in and around the solution, which adds latency and ultimately reduces the user's experience. So while Citrix have for several years had techniques to improve this situation, more recently they've come up with optimization techniques for various different platforms to provide the same native experience that you would get, again, if you were using a regular PC or laptop with Citrix, which I'll explain now. So there are several optimized platforms available, but as of today, the four that you see listed here are the most common. And I think we can back that up very quickly by just very quickly running a poll to you, the attendees, to find out what collaboration or unified communications platform you're running today. So again, I'd really appreciate that everybody can participate with this, and let's start to see what everybody's using. It's slightly different from this morning's results as it stands. So let's leave it a little bit longer to run. So again, it's slightly different to what we saw this morning, Rob. And we've got 83% voted. So I think that's good enough to share the results. Let me share the results on screen. So as you can see, yeah, slightly different to this morning. Still a resounding popularity for Microsoft Teams, but definitely a shift for Cisco WebEx and other as well. So for anybody who selected the other, feel free to comment about that that we might be able to discuss that perhaps at the end.
Cool.
So we've listed this slide here, which really details some of these platforms and more, and in terms of their level of support. So on the Tenzig side, if you're using a Tenzig thin client, whether we support them on our Windows-based endpoints as well as in Linux, whether we support the optimized plugins on our Linux-based clients. And in addition, as Rob touched on with his demo, we're using something like browser content redirection, and those applications feature a web app, you can use those in an optimized form in conjunction with browser content redirection. So that applies to Microsoft Teams and Cisco WebEx. Now, the demo that we're going to cover today is on Zoom. We've done, both Rob and I last year did an hour session on Microsoft Teams, so it feels wrong to sort of repeat that. So I will pop up the link to that shortly, so that for anybody who hasn't already implemented optimized Citrix version of Teams, please join that or play back that recording. Like I say, it's an hour long, and we go sort of very in depth on that in terms of both the architecture of it and also how to implement and verify that it's working. What I do want to cover today is broadly the framework, as we see here, the SDK that Citrix provide to these vendors, and to broadly cover that it's the same framework for each with some slight variations, and those variations really cover the unified comms application, in the fact that broadly it's the same, that it's always installed inside the virtual desktop or as a published virtual app, and it sits alongside the Citrix VDA, which is the bit that really encapsulates that and that communicates with the virtual channels, which I'll come back to in a moment, and then pair up with the Citrix Workspace app that sits on the endpoint, again, either a Tenzig thin client or another type of endpoint running Workspace app. And that in conjunction has a media engine, and that media engine communicates with webcams and headsets that are plugged directly to the endpoint. Now, that media engine is either supplied by the vendor. So in the case of Microsoft Teams, the media engine is integrated natively into Citrix Workspace app. But for something like Zoom, there's a media engine plugin that is integrated alongside the Workspace app, and it's Zoom in this case who maintain that, and also Tenzig, for example, on the Linux clients, where we integrate that plugin, we basically bake it into our firmware. Now, the application itself sits on the virtual app or desktop, as I mentioned. The app itself still continues to signal and authenticate the user as it would do in a regular desktop or a non-optimized format, as we can see on this slide. But the key to it is the bulk of the load, i.e. if the user initiates an audio or a video call, or in the case of Microsoft Teams, a screen share, they are channeled towards the endpoint through these virtual channels. So both the media and the call control virtual channel, and those things are encapsulated almost like the same slide that Rob demonstrated earlier when he was demonstrating the adaptive transport. So they're encapsulated there, and then enable the endpoint then to initiate the audio and the video directly. So the situation that you end up with is that the audio and the video is encoded directly from the endpoint, and that in this case goes directly from the endpoint towards the Zoom cloud services, as opposed to from the endpoint to the virtual app and desktop, and then down to the Zoom cloud services. So you're basically eliminating the virtual app and desktop from that point. And just like we saw with BCR, you're shifting the CPU and memory load and the network bandwidth from the virtual app and desktop to the endpoint. And we'll see that in the demo that we're about to cover now. And as I mentioned, that YouTube link that Rob and I covered Teams, let me just hand that into the chat here so that you can all reference that later if that's of interest. So that YouTube link is in the chat, and let's go back to the demo. So the first demo I'm going to provide. Let's just make sure is my screen sharing still working correctly? Yeah, it looks like it is. So let me go ahead and explain the demo. So this is the same platform that Rob was connecting to before, but this time I'm connecting with a user called Jane Doe. Rob was connecting with John Doe. So we're not husband and wife, we're just two demo users. And we're both logged into Zoom, but the difference is we're using the Zoom VDI version. And again, we both have an equivalent plugin that runs on the endpoint. Now, for the first demo, I'm purposely doing it from the Mac in the fact that I have free access to this and I can use a protocol analyzer to demonstrate the shift in traffic. So, for example, let's fire up Wireshark, and as you can see, this is an IO graph where let's just start the trace first of all. So I'm starting the Wireshark trace, and it's capturing the wireless traffic on the Mac. Let's again bring in the IO graph here. And if we filter firstly on TCP 443, this is the network bandwidth that's being consumed between the endpoint and the graphics remoting, and you can see it's very, very low. It's in bits per second, and that's really because there's nothing happening in the virtual desktop. But if I open Firefox, and I'm purposely opening Firefox because, as Rob demonstrated, this isn't optimized with BCR, so all of the graphics rendering is done in that 2 vCPU desktop, and then it's remoted down to Citrix Workspace app. And as we can see, that jumps the bandwidth up, and then if we start to play a video, we should see the bandwidth jump right up. So as we play in this video in a windowed mode, you can see already that the bandwidth in terms of encoding and delivering that is in upwards of 6 megabits, but it's averaging more around sort of 2 megabits. So again, that's capturing the network bandwidth purely for the Citrix desktop at this point. Now, if we then go to Zoom, and again, we can see that that's really tailed off and dropped to 0. Now, with Zoom, if we go into settings and we go to statistics, we can see that, again, when I'm connected from the Mac, the plugin is installed. We can also see here the CPU and memory consumption of my endpoint, as well as if we were doing any active calls, which we'll do in a moment, things like latency and jitter. So this statistics section is really good for understanding what's happening under the hood, and the fact that the VDI plugin is well connected. Now, if we go ahead and start the meeting that Rob and I booked beforehand, and you can see me in my home office here. So Rob will be joining. And again, if we take a look back at the Wireshark trace, again, we can still see that the bandwidth here is very, very low on the basis that the virtual desktop's not doing anything. But if we bring into view the UDP port here, is it still running? Let me just check.
See if it now connects. Now it's all connected. Okay. I have my Zoom meeting waiting, but he didn't connect.
Let me admit you in.
Sitting up straight, so.
Yeah, me too. Okay, so the blue graph this time is you can see is representing the Zoom video feed. Now this doesn't seem to be refreshing it. So let me just try again. The demo gods. Dark. Yeah, here too.
The demo gods. Yeah.
Yeah, the good old demo gods. We always hear about these guys. So there we can see again, it's capturing the throughput, which is representing that the audio and the video stream is coming from the endpoint. Whereas again, if we bring into view the Citrix desktop traffic, we can see that again, it's it's non-existent at the moment because of the fact that this particular portion of the video is all being done from within the Workspace app and the Zoom VDI plugin. So nothing at all is happening on the Citrix desktop. And the next demo, which I just want to cover to show you the CPU load. So let me quit out of this. 1 second. Quit out from here. So the next demo will be doing the same thing, but from a Tenzig endpoint, because it would be really unfair of me to do a demo without showing you the demo from a Linux endpoint. So this is a Tenzig, I think it's a 6048QC. It's one of our mid-range units. And again, the Zoom VDI plugin is baked into the firmware here. And if I go and connect to the same environment again from this endpoint, and we sign in again as Jane, and I have exactly the same problem as I had this morning, Rob, that I can't remember the username and password. So let me
TM at tmkm.onmicrosoft.com.
Luckily, the password I can remember. Okay, I connect to the same desktop. And whilst we're connecting to that desktop, if we just bring into view the SSH connection, so I'm connected to the endpoint via SSH, and then I'm running top, which is a Linux performance monitor, where I can see the load on the Tenzig client. So you can see the Zoom process is running here. So that again is the VDI plugin. It's very much idle at the moment with the fact that all it's doing is it's established the virtual channel, and also the CPU as a whole is low with the fact that it's really just idle. Again, if I go into Zoom and I go to statistics, this time we can see the VDI plugins connected, but it's Linux and not a Mac. And again, we can see the cores and the memory usage on the Tenzig client. Now, again, if we start the session as we did before, and we join, we can see Rob's still connected. This time I'm connected from actually an endpoint that's in our quiet office, with the fact that majority of people are working from home, including me. And whilst that's connected, let's look at the CPU usage on the virtual desktop. So again, if we bring Jane into view, we can see that very, very low CPU usage, mainly made up of the desktop window manager, as well as probably the task manager. And if we look towards the Zoom process, we can see even though we're in a meeting, it's very, very low, just 1.8%, as you can see, which is really just the basics of signaling and controlling the core of the app. But if we then bring Termius back into view, we can see now the CPU load of the Tenzig client is around 45%, with the fact that it is now encoding and decoding these video streams. And as you can see, it's really essentially overlaying the video on top. So as far as the user's concerned, it provides a seamless experience. So let's end that. And again, I'm not going to cover Teams, but if it is there, let's just prove the fact that, as you can see in Teams, we're also Citrix HDX optimized, with the fact that we're running a supported version of Workspace app on that same Linux client. So again, if you are interested in Teams, look towards that YouTube link that I mentioned before. So that concludes the Zoom demo. Hopefully that was useful. I just want to now touch on really just to support what Rob mentioned earlier around some of those Citrix features. So this table represents which of those features are supported on each Tenzig endpoint. So as far as Tenzig Linux, we're referring to our NOS 64 platform. So that would be models like the 5848QC, the 6048QC, basically anything that ends in 48C or 48QC. And for Windows 10 IoT, it's the models that end in 10. So again, a 584810Q or a 6010Q. So as we can see, adaptive display is supported across both. H.264 hardware decoding. So again, the codec that's used for video, it's supported on both, but with a caveat in Linux that it's only supported in conjunction with using full screen video codec. So if you're using the adaptive display and you have Linux, you have to use just regular H.264 software decoding, and you turn that option off. And that's a current limitation of the platform optimization SDK that we use at Tenzig for that particular feature. H.265 hardware decoding, which is a more advanced video codec for reduced bandwidth, is supported by Citrix Workspace Windows app, but not currently for Citrix Workspace Linux app. So if you do have an interest in that, which also requires NVIDIA Grid with support for H.265, then it's a Windows-based client that you need. And you can see the caveat here that it's supported on these current models. And then finally, for browser content redirection, it's supported on both platforms, but in Linux currently, it's supported via CEF, which is an experimental feature. So for sure, test that with your desired applications, as Rob demonstrated, and test it both on Linux and Windows to find out which is the right fit for you. So want to just really end the presentation by talking about remote management, because as Rob touched on before, this has been a very big and important topic for Tenzig over the last year, both with existing customers and new customers, where overnight the thin clients and zero clients were required to be pretty much sent home, and IT administrators were left with a problem in terms of having to manage not just Tenzig clients but all endpoints. So Tenzig Manager is our enterprise-free centralized management, and we were very lucky as a company that 4 years ago we embarked on the capability of providing remote management for Linux and more recently our Windows-based clients through the cloud, using our Cloud Connector, which is a component of the Tenzig Manager. And this provides businesses with lots of benefits and an integrated strategy for remote management, all at no extra cost, which is the really critical thing and important thing, since the tool is inclusive to Tenzig endpoints. So the management tool can be installed both on-premise or cloud-based with cloud platform of your choosing. And the real resounding feedback from our community is that the tool is simple to use and pain-free. You don't have to sit on a 5-day training course. Within an hour sort of overview, most users can get up to speed with it very, very quickly. And as well as providing a platform to shadow employees, all at no extra cost, it of course allows administrators to ensure the endpoints are fully secured and up to date. Now again, like other videos, we do have 3 specific sessions that are available on the Tenzig YouTube link. So I do encourage you to look at that if this interests you in any depth, and we can do one-on-one sessions as well if you have a deeper interest in that. So this is really just a quick summary of that with the time we have available in this session. So this first slide gives you an overview of remote management if you're using an on-premises based solution. So you have the Tenzig Manager as it is, running on a virtual machine that manages the endpoints internally, and then you can install the Cloud Connector to a standalone machine, typically inside a DMZ as we see here, to enable the remote management of endpoints at home locations or more traditionally branch offices and remote offices. And then we have the cloud-based technique where either all components are installed into the same virtual machine, or again, like in the previous example, those components can be put onto separate virtual machines dependent on load or security. So the next important point of this is to break down the network ports that are required to enable the remote management. So between the inside network where the Tenzing Manager server sits and the DMZ, on the inbound side, there are 3 ports required: TCP 50,000, TCP 8001, and TCP 52500. On the outbound side, and this is configurable dependent on the number of clients and the number of active jobs that are running, it's 30,000 and 30,250 by default. And just to explain, we establish a port for every simultaneous task that is run from the Tenzing Manager server. So, for example, if you have 10 shadow or 10 VNC sessions to 10 clients simultaneously, it's 10 ports. If you're running firmware updates to 50 clients simultaneously, then it's 50 ports. So that port range is configurable depending upon the number of clients and the number of jobs that you execute at any one time. And as a rule of thumb, we recommend typically that it's 2 to 3 times the size of your largest management group. So that's really just a guide there. And finally, we look at the ports required on the external side. So on the right side here, this is our outside network where the Tenzing endpoints are sitting at users' homes and towards the DMZ or cloud. So it's TCP 443, as it states. It is configurable and it's secured by a certificate, as we'll see. And finally, you can also support access to the web console. So we've for the last probably 4 or 5 years had the option of a web console, so administrators can sign in through Chrome or Safari or Edge, and this feature again permits remote access to your administrators to mitigate the need for, let's say, a separate VPN back to the main office. So the demo of this I want to just cover to finish off the session is the simplicity of how to set this up. So what I'm first of all going to show is this particular virtual machine. So let's minimize the shadow of the client. And this is the regular manager console. So let's say that this is running on premise. And as you can see, we have currently 82 clients discovered and registered inside the manager console. And these are filtered into different groups, including the group that contains that demo client that I was just connected to run the Zoom demo. Let's say that we've rewind back to March last year, and all of a sudden we've sent units home. And now, as an administrator, I have to install the cloud connector to enable remote management. So for best practice, I have a new virtual machine that resides inside my DMZ, and I take the Tenzing Manager installation. Make sure I haven't got. What do you have for your equivalent of sausage fingers, Rob? Is it? I can't remember what you use in Holland.
We have fat fingers.
Fat fingers, that's the one. So yeah, either sausage fingers or fat fingers to make sure we get the password correct. So this is the same singular install. Again, you can install all the components on one machine. On this occasion, I'm going to install just the cloud connector, and the critical part of the install is then pointing that towards the existing manager server. But before we do that, we just have to specify the port that the clients use. So again, it's 443 by default, as well as the certificate. So for the purpose of the demo, I'm just going to use a self-signed certificate, but you can use either an AD signed or a commercially generated certificate. And again, those YouTube videos cover examples of that. So this is the critical part of the install, where we have to enter the IP address of the Tenzing Manager server, as well as the Cloud Connector relay code. So the Cloud Connector relay code, this is where I have to make sure I've got the right virtual machine. So the Cloud Connector relay code is available on the Tenzing Manager server under our Cloud Manager settings. And as you can see, the code is provided to me here. So the relay code is a unique code that authenticates the Cloud Connector to the Tenzing Manager server. So I can use that relay code and go back to the installation and drop that relay code in here, as well as enter the IP address of the Tenzing Manager server. Also specify the IP address of the web console, assuming you want to use that feature, and also point the port number accordingly, so it's 50,000. So the install is going to create the self-signed SSL certificate, as well as install the cloud connector. So we'll let that go ahead and install. Just takes just a few seconds. That process is completed, and that already runs the service as default. So if I refresh the Windows services, we can now see we've got 2 additional Tenzing services, which is running the cloud connector. Now, it's worth just pointing out the cloud manager settings, and this is where we can review the settings that we did perform during the install, as well as optimize the connector as far as security, etc. So the first thing we would recommend you do is to disable TLS 1 and 1.1. These are there for older legacy clients, like our older 32-bit Linux clients running much earlier firmware. In the console tab, we can review the web console host and port, as well as if we want to disable the external web console relaying. So again, if you want to specifically block any external users from accessing the web console through the cloud connector, let's say that we made a typo during the install, we can change both the relay code and the IP address. And then under advanced, we have the login level. So it's always useful to show this just for the purpose of proving that A, we're connecting to the manager server, but also show the registration from the client, as well as enable the on-demand port allocation. So this is where you can either stick with the default range or change it depending on your needs. Before I restart this, let me go ahead and start the syslog. So the syslog is installed by the cloud connector, and I can view that. And as I restart the service, we can use that to verify the fact that we're connecting to the server. And that's good. So we can see here we've successfully connected to the Tenzing Manager server. And if we go back to the internal manager, we can still see currently there are 82 clients registered inside the console. But let's say I've got home, it's March the 23rd in the UK. I've been sent home by Boris Johnson, and I plug in my Tenzing client, and I come to the cloud manager, and I enable the Tenzing Cloud Management Agent, which, by the way, is installed by default. And I can either take the server address from DNS SRV, which can be used if we're using our own managed DNS, or I can enter the IP address or the fully qualified domain name here. I can test the connection, so we can see the connection is okay, but it warns us that the CA certificate isn't found because we use the self-signed. And I can then click apply, and that should then start the agent. And we saw hopefully in the background here that actually before I quit out, let's just OK that. And let's go to network. And so we can see the IP address of this client is 16.184.6. If we look inside the log, we can see again that the client's connected to the cloud connector, which in turn has proxied that towards the Tenzing Manager server. And then to finish off, if we go back to the internal manager, we can see the client is there. So that's, again, the same matching IP address. And I can go ahead and I can shadow that client just like I would do in an internal office environment. And I can also, as you can see, do things like firmware updates and reboot the client, etc. So that hopefully gives you an example of how easy it is to remotely manage the Tenzing endpoints, both Linux and Windows based. So hopefully that gave a good, effective demo, and that brings us more or less now to the end of the webinar. And just before we hand over to any questions, and feel free to start asking questions in the panel, let us just fire up the final poll, which is, if you're not already using Tenzig, do you require a free Tenzig demonstration or evaluation unit for trial? So again, yeah, really appreciate any responses to this final poll, and then we'll hand over to any questions that anybody may have. And I can already see there is a few incoming. So let me just close that poll. Okay, so we have a question around integration with Slack. How does Slack fare? I don't know if you can answer that one, Rob. If there's anything coming, if you've heard of any demand or roadmap for Slack.
I don't have the answer straight away. Integration with Slack, so that means Slack audio and video calls, I think. I don't have the answer right away, but if you give me the details of the person asking that, I will follow up on that. No, I don't have the answer right away, but I will get the answer.
Thanks, Rob. Yeah, so I'll follow up with you one-on-one afterwards with the person who asked that question. So thanks
the answer soon enough.
Thank you. We have then another question for those people that are doing a work from home and those doing a call center. So there's a via 1X and communicator using video conferencing with MS Teams and Zoom. Based on performance between the Linux and the Windows 10 IoT, would it be recommended to use Windows 10 IoT over Linux? Or if we're running the latest Linux firmware, it's a negligible performance loss compared to a Windows 10 version. I think ultimately, if the optimization if the optimization exists for either platform, certainly as far as we see with products or platforms like Zoom and Teams, there is very negligible, if any, difference in terms of performance. In some cases, it's actually better with Linux because of the fact that it's a much more finely tuned operating system. And again, like Rob touched on, it doesn't, with a Windows, especially if you're using a Windows platform like a regular PC or laptop, that has a lot of other bloat and a lot of other processes that are running that you wouldn't have on a thin client where it's just finely tuned for that purpose. If you're using something like a via 1X, where currently we don't have the Linux integration for that, then for sure the Windows 10 IoT platform is the right thing for that fit. So hopefully that answers that particular question there. And yeah, and thank you to Heather who was asking on Slack. So yeah, we might just leave it open for another minute or so just to allow any final questions to come in. But as we said at the beginning of the webinar, Rob, we wanted to get everybody finished if they were interested to see the inauguration, and hopefully we've achieved that.
I'm also going to watch them. I hope they haven't finished yet.
And yeah, I think it was due any minute, so we should get off in time. The person asking about Avaya, there was a timeline for 1X. At the moment, I would encourage you to speak to your Tenzig sales representative or even support if you don't have immediate access to that. It's really dependent on the demand for that particular platform. There was some talk of that last year, and there was certainly some demand, but we probably haven't quite seen the level of demand that we need at this point compared to the likes of Teams and Zoom and products like Cisco WebEx as well. So again, I would certainly suggest to talk to sales, and I will pick that up internally as well, just to point you in the right direction there as well after the webinar. So I think. Okay, so one final question. This demo was with or without antivirus installed on the OS. What about with AV? What is the minimum requirements for vCPU, VRAM for VDI, which you recommend?
There's a document at Citrix, I think at TechZone, where we talk about this thing. That's a valid concern, of course, because AV is really doing an impact on performance. There are some independent researchers about that also. I can't remember the site name that have been doing a research on that, but AV is something that you really should consider having impact on your on user experience and performance. The Microsoft Defender is, I think, even the best one, and is doing quite. They have extended that quite well. So I would look into Microsoft Defender for. I'm just not trying to get knowledge back into my head about those.
Yeah, and I think I think another thing that we've recommended before is it also can vary and change dependent on the AV platform that you run, and typically there are certain AV platforms who do in turn give their own recommendations if you're using AV within a VDI platform, for example, in terms of what exclusions you might make around Citrix. So it's also worth checking with your AV supplier, assuming you've already chosen that platform, for any white paper or best practice. I think
but there are some researches out there that really would help, because there are some, I would say, bad ones that really have a hit on performance, and it's worth looking at.
Absolutely, yeah. So hopefully, that helped, and just really like to again thank you everybody for your time. I hope you enjoyed it, and I hope it gives you some inspiration to either use Citrix and Tenzig, and if you're already using both, then to look at what other optimizations we've discussed and unraveled today. And thank you, Rob, very much.
Thank you, Kevin. Have a
Thanks,
good
everybody.
evening, everybody. Good afternoon.
Bye-bye.
Bye-bye.